Okay. Good morning, guys. Today our topic is PT. This is the potential transformer. Okay. And now you can see this is the picture of a photograph of a potential transformer. Potential transformer is generally used to measure the voltage in a transmission line. Look, not for our normal uh, conventional cases, but in a high transmission line, and then we have to 11 kV or normal distribution line, and uh, in these cases we have to measure the voltage. But if we use our normal meter, that is analog meter or digital meter, this is not capable of handling so much of voltage. So what happens, we need to step down the voltage level. Say we are using the 11 kV line, then also we have to use this. But this is a generally a step down transformer. PT nothing but a step down transformer. Okay, this is called potential transformer. Just remember, this is the potential transformer. Lots of questions are asking from this PT and CT. And now you can see the diagram. Yes, this is the diagram of the PT, and here is also CT is available there. First, I am talking about PT, then we'll go for our CT again. CT was the next previous classes. Okay, look here. This is the 11. This is 110 kV. It is showing that 11 kV or maybe more than that. And now, if you going for measure the voltage, it is not capable of human effort, because if human just come to the close here, it will just blast. And now what happens, we need a potential transformer. Potential transformer means looks just like a step down transformer. So so many questions are coming. Just like I am talking about the tricky question, you have already known that is the potential step down transformer. But someone, if they someone call the number of turns in the primary side of a PT, it is less. Is that correct or not? Just remember this diagram, because this is the step down transformer. So primary side always connected with this feeder line. This is the feeder line, and it is say this is line and this is neutral, or maybe vice versa, anything. But look, the number of turns in primary side is much higher than the number of turns in the secondary side. Okay, or somewhere asked in PT, the high tension number of turns in the high tension side is HT side is high or low. Just remember, this is always high. Number of turns and is much greater than the secondary side. This is secondary side where we are getting some induced voltage. Okay, so PT is calibrated in such a way that maintains some ratio. We know the transformation ratio, and there is, so if there is a 100 volt is passing here, then in the secondary side it is just induced just 1 volt. Okay, in this way we have to, the highest range and lowest range is just step down up to a certain and limitation. Say this is 1000, this is 1000 volt, then it will come this is 10, because ratio is maintained. So 1 to 10 volt, it is the measurable area of your or analog measurement, or somehow it is also measurable, easily measurable by your digital meter. So in this way, if we just measure the 1 volt, then actually we are measuring in the primary side, this is 100 volt. If we measure the 10 volt, then it is always 1000 volt, because step down ratio is such a way that it is the ratio is 100:1, or it may be vary whatever are required. So in this way, if our voltmeter is measuring actually 1 volt, then we can assume that is it is the transmission line carrying the 100 volt. If our measuring voltmeter is measuring 10 volt, then we can assume that our transmission line is carrying 1000 volt. If this is measuring 100 volt, then it is we can say this is 10,000 volt, because ratio is 100 is to 1 step down ratio. So we can measure actually 100 volt, but scale is set it such a way that it shows the voltage at the transmission line, because ratio is same. So whenever pointer deflected say theta 1 degree, they are showing that is 100. If it is deflected, pointer deflected with this is theta 2 degree, much say 10 degree, then it is showing this is 100,000 volt. If this pointer is showing the much, this is the theta 3, or 10 degree more, then it will show, look, this is the 10,000 voltage. In this way we can measure the transmission line voltage. So this is the fundamental things of a PT. This is potential transformer. And never say this is the power transformer or any other form. This is PT, P for potential, T for transformer. Potential means this is measuring the voltage. Okay, potential difference it is measuring. So this is the main things of this is potential transfer. Now I am talking about the CT. Yesterday, previous classes, you have seen the construction of CT, and now CT is connected in this way. This is another hybrid formation of the CT. In normal your panel, your distribution panel, or your any other panel where the CT is used generally under 100 ampere, generally it is measuring 64 32 ampere, then nothing is there one rod is there, one rod means one bus bar is there, and surrounding this a CT, just like in this form, a coil forming CT is there, and here is the two wire is there, it will carry the current. This is the current transformer. But in case of much higher current is there, when above the 100 ampere current is flowing, then what happens? A direct CT is there, then another transformer like step down it is doing there. Look, in this case, what happens? In transmission line, the number of turns is less. Say this is the 10 number of turns. But in the secondary case, where we are attaching a ammeter, there the number of turn is just like 100. What happens? Look, this is the 10 number of turns, and this is the number of turns is say much there. Then say it is the 100. Why it is required? Look, we know that in a transformer ratio, P1 equal to P2. P1 equal to P2. Somewhere some questions are asking P1 equal to P2. So if the secondary side V is higher, then I must be less. Say P1 equal to V1 into I1, and there is power factor is cos phi, and here is V2 I2, and power factor is same cos phi or cos theta, whatever may be. So if look, if we have to less the current, then what happens? We have to increase the voltage level, and here we are already giving high amount of current, just like a 100 degree, a 100 ampere current is flowing. Look, 100 ampere current is flowing through the city in the primary side. So we have to convert it into 10 ampere, say 10 ampere or more less than it, say 1 ampere maybe. then what happens? We have to reduce the current level, so then we have to increase the voltage level. That's why in the CT, if there is a transformer formation, then the secondary side is the higher higher number of turns, because it increase the voltage. Look here, V1 I1 cos phi equal to V2 I2 cos phi. Okay, so if P1 equal to P2, then cos phi is the same, cos phi is the same both sides. So if here I is much high, so 100, so you have to maintain the V small, and in this case, secondary case, is we need to reduce the I. So if I reduce the I, look, I am writing the I in a small, then we have to increase the voltage level. Then P is the same, P1, P2 will be the same. So in this case, I is high. So in the secondary case, we need to increase the voltage. Then we get the I in the less form. And then we already know that this is the ratio. 100 is showing the 1 ampere, and then 10 is showing zero point 0.1 ampere, and it is easily measurable by your instrument, by your measuring instrument, just like MI type instrument, dynamometer type instrument, or your or digital instrument. Then we can easily change the scale, if just like vice versa. If your ammeter is measuring 1 ampere, actually transmission line is carrying 100 ampere. If your meter is measuring zero point 0.1 ampere, then actually your transmission line is carrying 10 ampere. In this manner, we can measure the current flowing through the transmission line, and then we have to just change this scale L up to the requirement. This is called calibration. Okay, so in this way, we can measure the high amount of current and high amount of voltage of transmission line, distribution line, or any of your feeder line by your CT and PT. So guys, I think the concept of CT, PT and application are quite clear to you. If you have any question, you may ask me, and then I will go for the next topic. Guys, have you any question?
Sir, I have studied from somewhere that and heard the name of capacitive voltage transformer. So it is same as PT or something different, sir?
No. Capacitive voltage transformer is not like this. This is CT, current transformer. Okay. This is only CT. This is means stands for current transformer. Okay. Or here is the
No, sir.
PT.
PT. Yes, sir. PT or
PT is
and
stands for,
capacitive voltage transformer is a different.
it is a difference. Then we have to put some capacitive voltage in load. Then reactive var, I just going for the next topic, that is reactive var or your var measurement. Then you can find some other like voltage var measurement. Then you can get, this is inductive load, capacitive load. But this is CT and PT. This is universal. This is known to in this name. Okay. And
Yes, sir.
if you asking, it is your uh, higher level study, when you are going for power system 2, then you can introduce with FACTS controller, flexible AC transmission line. Okay, in this case, you have get some devices which is comprised of capacity, inductance, which is control the transmission line var. Okay, and then you can get some topic. Okay, now it is okay. I am going further. If you have any question, then if you not have, then I am going for other. Okay. Okay. Now today our topic is another topic. This is a reactive VAR measurement, or you may say this is reactive power measurement. I think guys you have already studied the active VAR, reactive VAR, active power, reactive power in your basic electrical studies. Uh, so what do you mean by active power and reactive power? Guys, we are getting P equal to P equal to VI cos theta, or somewhere you can read cos phi. So this is the active power. We already know this. Uh, P equal to V into I into cos phi for the AC. This is the active power. So whenever there is a cos function, there must have some sine function also, because if it is the line, then if we say this is our cos phi terms, this is the, then we have some, if this is the phi theta, then it some have some sine theta also. So this sine theta terminal is called your reactive power. Okay. Say I am now I am saying the another way. Uh, Say this is your cold drinks bottle. Okay, this is your cold drinks. Say this is thumbs up or anything you may see in your bottle. You uh, you all have seen up to this level there is some cold drinks is there, but in this area there is vacant. Okay, this is the vacant, this is a gas, or you may say this is the air, or may say this is the carbon dioxide gas, because this is the laminated soda. So this is the water liquid. Okay, so without air, if you go to buy this cold drinks, you never buy only this water level. You have to buy also this air level also. Without this air, you can't buy this bottle. If you say you went to a shop, you demand a cold drinks, just like say any brand, like brand, a cold drinks, and then you say no, I only need the water side, we don't need any air in this bottle. Could you able to buy this? No, you have to buy total bottle. So if total bottle is our total power, then within this only this amount is filled of water, and this amount is filled with air. Just like a lace packet, there something is potato chips is there, and any other area is covered with some nitrogen gas, or some gases is there. So this is the concept of power. This power is called, this portion is called active power. Active power helps us to blow the bulb, helps us to produce heat or energy. And reactive power, this reactive power does not applicable for any working. That's why this is called the true power, and this portion is called alt, just like a reactive power. Now question is that, so what is the function of this reactive power? Say in this area, if air is removed, then full portion is filled with this water or liquid. And if sometimes whenever you open this cap, then some of portion of your water or your drinks, cold drinks, became overflowed from this bottle. Have you seen this? I think you have seen this. So this is the function of this is reactive power. If a transmission line, if reactive power became less, then the active power became high. So after a certain amount of increment of active power, then it will goes to the some fault is there, or some heat generation is became much higher. So that's why, as well as we are using the vi cos theta portion, then we have to carry the vi sin theta portion also. So this is the reactive power and the active power, and this is totally called the apparent power. This total power is called apparent power. Apparent power. Okay, this is called reactive power. Reactive power. This is called active power. Okay, guys, I think you all get this point. If you have any question, you may ask me. I think the concept of active power, reactive power, and apparent power is clear. And then I am going for the next step. Look, you have seen this is normal active power is denoted by P equal to V. Look, P equal to Vi cos theta, and this is active power, and reactive power is denoted by this Q. This is V into I into sine theta. This is active power, this is reactive power, and total apparent power, this is apparent power is denoted by just normal S. S is denoted by P plus Q. Okay, this is the apparent power. So we have to measure in a transmission line, both this quantity are available. Both this quantity are available. So if we go for the uh, triangle format, then we can get the we can get in this way. Look, triangle. This is the active power. This is the active power. Uh, this is the reactive power. Reactive power, and this is the apparent power, means total power. Okay, and this is your power factor. This is theta is your power factor. Okay, or another way we can write in another formation that is also available. Guys, do you get this point? Then I one by one I will explain. So this is the vector sum only. Okay, don't say this is the sine theta cos theta form. This is the vector sum only. This is the active power and reactive power. This is called triangle format. And you can write down the note against this reactive power. And this is the reactive power is a power which is flow back and forth direction. Means not only in one direction. This is flow in back and also forth in both direction. That's why this is not come to the point of action. And in this circuit or a reactive reacts when it is just like a open, it is called the reactive power. Okay, and you may say the reactive power is whenever it is in the opposite direction, it behaves like a open circuit, and whenever it's flowing through the in a forward direction, it is behaves like a closed circuit. Okay, in this way we can measure, we can realize the reactive power also. The reactive power is measured in the kilovolt ampere reactive, or you can say this is, look, kilovar, kilovolt ampere, and as this is the reactive, then it is var, var. This is reactive var, kilovolt ampere reactive var. And this is the only power. If you count this var with respect to time, then it will become a reactive energy, kilovolt ampere hour, or kilovolt reactive power hours. Okay, or somehow it is measured when your transmission line, high transmission is flowing, then it is measured in kilovolt. Instead of kilovolt, it is became the mega. Okay, megavolt ampere reactive. And the component which is, hello, hello, and the components which is proportional to the vi sin theta is called as reactive power, and the represented in the form of which represented in the form of q. Okay, so we have this is the we have the idea regarding the reactive power. But I think you have also get the idea why reactive power is required, because in your flexible AC transmission, in your higher study you have seen flexible AC transmission, that is called fax, and some controller is there which controller controls the reactive power. If reactive power is became very less, then what happens? Reactive power became less, then this active power became very high. Okay, because this is the formation from the vector summation. This is the vector summation. Okay, this is not a polar summation. Polar is another way. Then what happens? Then it produces much amount of heat, and which will causes any trip or a high amount of current. Means the reactive power, active power only come to the action. Active power is applied to produce heat. Active power is applied to run this motor. Active power is used to dissipated in your load only. Okay, and reactive power, it is not in any action, because it sometimes flow in this way, sometimes flow in opposite way, whatever maybe, it has no root actually. Okay, uh, so this is the idea of the active and reactive power. Now, how could I measure this reactive power? How could I measure this reactive power? Look, in your wattmeter method, you can measure your reactive power also. This is the idea of single wattmeter method. I am just drawing this red, yellow, blue. Look, this is the red. This is less time is there. Red, yellow, and this is your blue. Okay, so load is there. Load is there. Say I am trying this in this way. Load in this way, load. In this way, this is the load is there. Okay, so this is the load. Now, oh, how could I do this? Look, wattmeter is connection. Normal wattmeter is connected. You have seen this is the current coil. This is the CC. This is the current coil. You have seen in your wattmeter there is the current coil. And don't connect the M and C. Just connect your M. Just connect your M in this way. Look, this is the potential coil of your wattmeter and connect it to this point, and this is your wattmeter. So in this way, whatever wattmeter will show, this is the actually this is the reactive power, and as this is the three phase, as this is the three phase only, then we can find the whatever may be reading. Say wattmeter reading is W1. Wattmeter reading is W1. Okay. So reactive power is Q equal to, as this is the three phase, then we have to multiply with the root 3 into W1. This is the reactive power measurement of the three phase. Okay. Uh, in this way, we can measure it with a single wattmeter. It is using single wattmeter. This is the P power coil, or the potential coil, or the voltage coil, not power coil. This is the potential coil. This is the voltage coil. Actually, in your wattmeter, there is a connection of just like this. This is a connection of M, L, com, V. Okay, ML com V. In normal cases, M and com is short circuited or connected, but in these cases, whenever we are going for the measurement of reactive power, then this connection should be crossed, open, and look, this is ML. This is acting measuring the current effect, and another two potential voltage difference is doing this. So you can say, how is it possible? What is the action is doing there? Look, in this case, we can write down a, phasor diagram. We can show. Look, in this way, in this way, this is the 120-degree apart, one each. Okay, so I is just deflecting with some value with this voltage A. This is I, this is I, and do if I do the another way, this is I. Look, this is the VA, this is VA, this is VB, this is VB, and this is VC. Just like this, VA, VA, VB, and this is VC. Okay, so if I write draw this another negative, just like opposite direction, this is VC, this is minus VC. You can see this is 120 degree, this is 120 degree. Okay, and then VC and VB, within this we are get VBC, 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 and VBC is here. VBC, this voltage is measured, this voltage is VBC. So this voltage is VBC, this voltage is VBC. So this voltage V and I is there. Okay, look, here is this is and this is the 90 degree. This and this is the 90 degree. So this is the 30 degree, because 120 degree minus the 90, this is the 30 degree. Okay, so in this case, what is the A, and this angle is called the A. Okay, sine angle A. this is the this from VA to VBC, this is 90 degree and this is A. So what is the this amount VBC to I? VBC to I is just 90 degree minus A, 90 degree minus A. So we say a P equal to, if reactive power equal to this V into I is V into I, this is cos 90 degree minus A. Cos 90 degree minus A means V into I sine theta. Sine theta means sine A here. This angle is A. So this is the reactive power. So we are measuring, this is the reactive power. So this reactive power is multiplied by the root 3. That's why this is this is became Q. And why this is root 3? We know the V, actually this is the root 3 into VLL and VL sine theta. And you may say the Q equal to only 3 into phase, V phase into I phase into sine theta. So anyway, you can write, so Q equal to root 3 into W1. And why this is showing the reactive power? Because you can see this is 90 degree minus E. And that's why this is producing not VI cos theta, this is producing VI sin theta. VI sin theta, you have seen this is the reactive power, and reactive power is measured by the single wattmeter method when the connection is in this way. Look, connection is not M and C is connected, only M and C separated. C point is connected with the B and B point is connected with the another source, another line. In this way, we can measure the reactive power. Okay, and if you apply some counter with the hour, then we can get the reactive var energy, reactive var H. Okay, in this way we can measure. Guys, have you any question? If you have any question, then I think you can get this connection diagram. Then whatever it is reading, this is W1, it will be multiplied with the root 3. Then we can get the reactive power. Okay.